Welcome everyone. Welcome to this session on synthesis and RTL coding. So again, in this session, we are going to continue from the previous session. We are going to see some interesting synthesis simulation mismatch issues. We have already seen this during our lecture in the classes. We are going to see the same in the labs today. Okay. So this is another interesting synthesis simulation mismatch because of the blocking statement that's going to happen. The file is again present in the same standard area. The file name is blocking underscore caveat.v. So let's see what actually this file contains. And okay, so it's a very simple code. Basically, we want to OR A and B. I think we discussed this earlier also. So let us note what is the aim here. What is the aim here? The aim is to create this logic OR AB and it with C. This is A, B, C. This is my Y. This is the aim. I want to create this logic. Clear? Now, in the process of creating this logic, we wrote this in the form of this Verilog code here. So this is the Verilog code you're seeing. Clear? So we have created X is equal to A or B and D is equal to X ANDed with C. So this intermediate point, we are calling it as this intermediate point, we are calling it by the name X. Okay. So X is A or B and D is, or sorry, this is called D. Okay. This is not Y, this is D. So D is X ANDed with C. There's no problem here, but the only problem is we have written this as blocking statement. So because of the nature of the blocking statement, first D is equal to X and C will get executed. Then X is equal to A or B is going to get executed. This is going to get executed first, then this is going to get executed. So that means by the time this statement for D is getting evaluated, the value in X is old value of X. The new value of X is not yet computed. So this will look as if X is a flopped output, because then only X will have the previous value, correct? As if X is a flopped output in simulation. Let us see what is happening. This is going to be a very, very important point here. Let's see. So first let us do the RTL simulation. So iverilog blocking caveat.v and the TB is TB underscore blocking caveat.v /a.out gtk wave. Let's see what happens. Clearly this RTL simulation, I'm seeing only UUT. I'm not seeing any underscore U underscore 1 underscore 2 like that. So let us plot the signals. A, B, C, D. Okay. X is an intermediate signal. We will not worry. Let us look at this. This is a very interesting observation here. See, this is the beauty, correct? What was the Boolean expression we were creating? A, this is the expression we were creating, correct? A ORed with B, A ORed with B and C. Look at this point here, please. Kindly focus on this point. Here A is low, B is low. That means A ORed B will definitely be low. The output of OR gate, the X is definitely low here. And if I AND it with C, definitely the output should be 0 here at this point, correct? But what is happening? The past value of X, A and B, A or B is 1 here in the cycle before. That value is getting ANDed with the present value of C. It is as if the output of A or B is flopped and it is ORed with ANDed with C. That's how this waveform is looking. Otherwise, clearly this waveform cannot look high here. And see, A is high here and output is going low. A or B cannot be low when A is, see, this is A or B and C is 1. When C is 1, A is 1, the output D should be 1. The output D is going 0. That is because it is evaluating the condition here. Here A is 0, B is 0, so the output of the OR gate will be 0. ANDed with this AND gate will be 0. So clearly it is looking at the past value. Correct? Correct? Clearly it is looking at past value. This is looking as if there is a flop here. Correct? This is not the real behavior. Correct? Now let us synthesize this and see what happens. So as our reference, we will take the snapshot of this RTL simulation, and this is the point of our interest. Correct? This is clearly the point of our interest. Let's see what is happening. Okay, this is my RTL waves. Correct? Now let us do the GLS first. So for that we need to synthesize this.